Okay. So looking at simplifying rational expressions. So at the top of the page, we see examples of rational expressions. They give us 3. So that would be 3 over x. We have x plus 1 over x plus 2. And x plus 3 over 2x squared. So each of these is a rational expression. A rational expression just means we have a variable in the denominator. And really why that is important is because a variable can represent any number, right? So with that in mind, there's that rule, or kind of that one of those golden rules of math, and that is we cannot divide by 0. That's just not possible. And because a variable can represent any number, that means we've got restrictions on these numbers. Okay, so we've got excluded values. So if I'm looking at this first rational expression, every number works other than 0, right? X cannot equal 0. If we do, then we're dividing by 0, and that's just not possible. So we have a hole in the graph at that value. For our next one, we have x plus 1 divided by x plus 2. This time, the x value that we cannot have would be -2, right? -2 plus 2 gets me 0, and then I'd be divided by 0. So this time my excluded value would be -2. On our last one, it's going to be 0. Anytime you just have multiplication or something raised to a power, or a variable raised to a power, it's just going to be 0, right? 0 squared is still 0. 0 times 2 or any other number is still going to be 0. So anytime it's just a variable or multiplication times that variable, it's always going to be 0. It's only when you have a plus or a minus that you're going to fall either to the left or to the right of 0. And again, the way you find those values that are excluded, take your factors and just set them equal to 0 and solve for them. Okay, so we're going to do a few more of those. To simplify a rational, we kind of have 3 steps. First step would be factor the numerator and denominator if you can. Second step would be identify any variables or any zeros that are excluded to make the expression undefined. And the last thing is cancel out any common factors. So let's go through some practice problems. So our first one, we got 24x to the 6th divided by 8x squared. So in this case, there's nothing we can factor out in the top or the bottom because they're single terms, but we can exclude our values. What would our excluded value be? 0. Right? 0 squared, still 0 times 8, still 0. So that's part of our answer. And then we can simplify this. So we have 24 divided by 8. It's going to get us 3. X to the 6th is bigger than x squared, so our x is going to be in our numerator. It's going to stay up top. And again, when you divide by exponents, you really just subtract the exponents. So that's going to get us 3x to the 4th would be our simplified version, right? 6 minus 2, we're left with a 4th. Everything in our denominator is canceled out. It would be over 1. Of course, anything divided by 1 is just itself. So our denominator is completely gone. Okay. Our second example.
Wait. I don't understand the x doesn't equal 0 or whatever.
So x cannot equal 0 because if we do have 0, we're dividing by 0, right? 0 squared, or 0 times 0 is still 0. And then 0 times 8 still gets me a 0 in the denominator.
Why do I have to put that? I don't.
So we cannot divide by 0. That's just one of the rules of math, right?
Do you have to write that down?
Yes. So we always have to put our excluded values. Okay. So like on this one again, can't plug in -2. -2 plus 2 gets us 0, then we're dividing by 0.
Okay, so if anything equals 0, you just can't put it?
Can't put it in the denominator. Okay. So let's look at our next one. We've got x squared minus 2x minus 8 divided by x squared plus x minus 2. So in this case, our first step is we've got to now factor. So to factor the top, again, it's a trinomial, and we have a trinomial in the denominator. So the first thing we want to do is we want to look at our c value. It's negative. There's only one way we can get a negative product, that is to have a positive times a negative. So we're looking for two numbers that multiply to get 8, whose difference is 2. So our factors of 8, of course, we've got 1 and 8, 2 and 4. The difference of those two would be 2, but we need a negative 2.
Mr. Howard?
Yes.
I need Sophia Smith to come down the list, please.
All right, she's on her way.
Thank you.
So that means we're going to have a negative 4 and positive 2. So negative 4 plus 2 gets us a negative 2. 2 times a negative 4 gets us a negative 8. So there's our top factor. Now we need to factor our denominator. So again, same idea, look at your c value, it's negative, so again we have to have a positive and a negative. We need a positive 1 value, 2's prime, so our only two options are 2 and 1. So 2 minus 1 gives us that positive 1. So now we need to do our restricted values, or excluded values. So x cannot equal, we've got two things in our denominator this time. So x cannot equal a negative 2, and x can also not equal a positive 1. Both of those values would get us a 0 in the denominator. In our third and last step, simplify what we have in the top in our numerator that we have in the denominator. So x plus 2 is in both the numerator and the denominator. Anything divided by itself just becomes 1. So we can essentially just mark it out. And we're left with x minus 1. Have a good one. Over x minus 1. And that's our simplified answer. Okay. So let's look at a couple more examples, and then we can go to them. So number 1, x squared minus 2x minus 3 divided by x squared plus 6x plus 5. So again, that first step, we want to factor the numerator, factor the denominator. So what is the numerator going to factor into? Plus minus, so the signs, we've got to have one positive, one negative. 3 is prime, so our only options are 3 and 1. But we need that negative 2. So that means we have to have a negative 3, positive 1. 1 minus 3 gets us that negative 2. Times negative 3 gets us that negative 3. Then our denominator. This time we have a positive 5. So we're going to look at our b value. It's also positive. So our signs are both positive. So we need factors of 5 that add together to get 6. 5's prime, so there's only one option. 5 and 1. So now we need to do our excluded values. So x cannot equal what gets us 0 in the denominator. So if we have x plus 5, our excluded value would be negative 5. And the excluded value for this factor would be negative 1. Cancel out what we have in the numerator and the denominator. So that's our x plus 1s. And so we're left with x minus 3 over x plus 5. Number 2. 20x to the 9th over 4x cubed. In single terms, we can't factor it, but we can simplify it. But before we simplify it, what is our excluded value? 0. It's just multiplication. So it's always going to be 0 when it's just multiplication. What does this reduce down to? What's 20 divided by 4 get us? 5. 5. What does x to the 9th divided by x cubed get us? X to the 6th. So there's our answer. And our last one for the notes. We've got x squared minus 4x divided by x squared minus 5x plus 4. What does that numerator factor into? X plus 2. That would be right if we didn't have that x there. So it would be a perfect square, but we have this x. So what do we need to do with those x's? Divide. We need to take out that greatest common factor, right? They both have an x. So we take out the greatest common factor of x, and that leaves us with x minus 4. And then our denominator, so we can factor that as well. And I have a positive c value, so I'm going to use the same sign as my b value. It's negative. So a minus and a minus. So what two numbers multiply to get 4 and add together to get 5? Well, that would be 4 and 1. So my excluded values, x cannot equal the positive 4. 4 minus 4 gets me 0. So 4 and 1 minus 1 gets me 0. So there's my excluded values. Now to simplify, cancel out what we have in the numerator and the denominator, and we're left with just x over x minus 1. Now a common mistake I see is people would then cancel out the x's. That negative or that minus 1 is all one thing, right? It's one factor. So we can't just cross out the x's, right? Either cancel out everything that's attached with a plus or minus or nothing. There's no getting rid of one piece of that. So that's our notes for today.